Hi everybody. Alright, so the goal of this is to help you review for your test. So I'm going to review some of the basic notes that we've gone over in the past 3 weeks. So there's going to be a bunch, so I'm going to be going on and on and on, okay? I'll try not to talk too fast. Alright, so first up, we start at the beginning. For this test, make sure that you know what the word astronomy means. It is the study of the universe. Make sure that you know that outer space is the physical universe beyond the Earth's atmosphere. So we have the Earth, and outer space is anything beyond the Earth's atmosphere. Those are 2 important words that you should know. Exploration is the action of traveling to a place you haven't been before and learning about it. You go somewhere new and you learn about it. A lot of you guys are explorers because you've come to New York for the first time and are learning about what it's like here. The moon. We consider the moon a natural satellite. A satellite can be natural, like the moon, or it can be man-made. And satellites are bodies or anything that orbits something that's larger than itself. So the moon is smaller than the Earth. The moon orbits or goes around the Earth. That makes it a satellite. Anything that orbits or goes around something bigger than itself is considered a satellite. It can be artificial, so man-made. We have a few man-made satellites up in space, like as you see here in this picture. And it can be natural, like our moon. Remember, our planet is not the only one to have moons. Many planets in our solar system have moons. Alright, so one of the other things I want you guys to know about is the Apollo 13 mission. So remember, the Apollo 13 mission was that mission that NASA had that was on its way to the moon, but 2 oxygen tanks exploded. They were limited in their power, their heat, and their water. And they had a CO2 removal system that was broken as well. So those are all challenges that they faced. These challenges they needed to overcome. They had to deal with their loss of power and heat and water and the buildup of CO2 in order to survive. And luckily, they did survive. I showed this video in class to you guys to show you that the Apollo 13 groups did come back all in one piece. So another question that I wanted to go over again one more time is why was it important to tell time in the past? This is something that we discussed in class, and what a lot of you guys correctly decided was that they needed to tell time in the past because they needed to know when to collect food, when to harvest food. They needed to grow food to eat, to sell, and to fund wars. But really the most important reason why they needed to tell time was to know when to harvest and when to plant. Food drove a lot of that back then. Alright, some more vocab words that you guys should know. A year is the amount of time that is required for the Earth to orbit around the Sun. So if we have this lovely orange liquid water, will be our Sun. This is our Earth. A year is how long the Earth takes to go around the Sun. So that's 1 year. That's another year. That's another year. So every time the Earth goes around the Sun 1 time, that's a year. Now a month is how long the Moon takes to orbit the Earth. So has nothing to do with the Sun, has everything to do with the Moon. When you see month, think moon. The moon takes 1 month to go around the Earth. A day is how long the Earth takes to spin around 1 time. So when you see the Earth spin around 1 time, 1 day has passed. Let's see what else is important from these slides. So a couple of other things that I want you guys to know from these sets of slides are the astronomers. So we have Ptolemy. Remember, the important thing about Ptolemy was he believed the Earth was the center of the universe, the center of our solar system. He was wrong. But that's what he believed. And he believed that for the rest of his life. And it is the most popular theory in Europe. For the next 1,500 years, people are like, this is the thing. So for the next 1,500 years, everyone believed Ptolemy. Ptolemy believed Earth was the center. It wasn't right, but that's what he believed. The one thing Ptolemy was good at, though, was predicting the motions of other planets. He did that better than anyone else at his time. He may have been wrong about what is the center of our solar system, but he was pretty good at predicting when we were going to see a star or a planet appear. Another important astronomer is Copernicus. Copernicus believed the sun was the center. He believed the sun was the center of our solar system, and it was a revolutionary thought. It was brand new, and a lot of people were not happy about the fact that he did not believe Ptolemy. But Copernicus led the charge of believing the sun was at the center. Galileo, he discovered that the planets, the ones besides Earth, were actually planets and not wandering stars. Hubble discovered that there were other galaxies besides our own Milky Way. This was such an important discovery, they named a telescope after him. The best telescope, in fact, the one that's in space. Huge telescope. Alright, so the other thing we need to talk about here is the moon. How did the moon begin? The moon begun when something large hit the Earth and it blew things off, like rocks and dust. It all blew off the Earth and it formed together to make our moon. So that happened in 3 steps. 3 steps. First step is impact. In impact, the Earth gets hit. That's what happens in impact. The Earth gets hit. At ejection, after the Earth gets hit, a lot of rocks from Earth explode off the Earth. The rocks explode off. And in formation, all these rocks that have exploded off the Earth slowly start forming as they go around Earth into our moon. So again, in impact, our Earth gets hit. Ejection happens. Some of the Earth flies off the Earth. That happens during ejection. And then in formation, these parts that flew off the Earth come together to make our moon. So the formation of the moon happens in 3 steps: impact, ejection, and formation. Here's another good picture for it. Impact, ejection, formation. 3 steps of forming the moon. Alright, so let's now move on to the sun. So there's a couple of important things we need to talk about when it comes to the sun. One of the most important things that we need to talk about is that the sun gets its energy through fusion. So remember, fusion is difficult. I don't expect you to know all the parts of fusion. What I do want you to remember is the sun gets its energy from fusion. It takes 2 different atoms and smashes them together. And when they smash together, that's fusion. And when they smash together, it makes energy for the sun. And I want you to remember that the sun makes these fusions 620 million times a second. So another important vocab word coming up, or 2 in fact, the way we measure distance in outer space. So we measure distance in 2 ways. Remember, space is huge. We cannot just use meters. We use 2 different things. We use an astronomical unit, and we use a light year. An astronomical unit is 150 million kilometers. That's the distance between the Earth and the sun. 150 million kilometers. An AU, or an astronomical unit. The other unit that we use in space is a light year. A light year is 9.6 trillion kilometers. It's huge. A light year is the distance light travels in 1 year. So if you set up a measuring tape and let light go for 1 whole year, you would need a measuring tape that's 9.6 trillion kilometers. It's huge. That's 1 light year, and that's how we measure distance in space. So, something else I want you guys to know is the different stages of the sun. So, the stages of the sun, they start with a nebula. Nebula is just a cloud of gas and dust. After a nebula, we have a protostar. A protostar is when this gas starts spinning around. As it's spinning around, the center gets hot. And the hotter the center gets, the faster it spins around. And slowly, as the gas spins around, it sucks all the gas inside until eventually you get a main sequence star. The important thing to remember about a main sequence star is our sun is a main sequence star, and a main sequence star is powered by fusion. Those are the 2 important things to remember about a main sequence star. After a main sequence star, you can get 2 things. You can get a red giant, or an even bigger star called a supergiant. Those are the 2 things you can get after a main sequence star. If you have a red giant becomes a white dwarf. It's an old star, and it'll get smaller and less bright every year until eventually there's no more light. A red giant becomes a white dwarf. A supergiant, which is bigger than a red giant, doesn't go out quietly. A supergiant goes boom! A supergiant becomes a supernova, which is a star explosion. And sometimes these star explosions form black holes. Black holes' gravity is so strong that not even light can escape it. It drags in all the light, and that's why it's so dark. Nothing can escape the gravity of a black hole. So the other thing you guys need to know are the planets. So I'm going to go over the planets really quick. Remember, our planets can be divided into inner and outer planets. Our inner planets are close to the sun. There's Mercury, Venus, Earth, and Mars. They're small and rocky. Our 4 outer planets are Jupiter, Saturn, Uranus, and Neptune. They're our gas giants. They're huge and have many, many layers of gas. Alright, so let's talk about those planets. So we have, let's get to it, we have Mercury. Mercury looks like our moon. It is the smallest planet in our solar system, and those craters were formed by rocks hitting Mercury. Venus, the sun rises on the west because it spins in the opposite direction of Earth. Air on Venus is made from carbon dioxide and acids. And temperature on Venus is high because of the greenhouse effect. Earth is great for life because of its water. The water is not frozen or boiled away. The perfect temperature on Earth allowed water to exist. And this water helped create life. It's key for life. The water is key for life. Mars is a cold planet because of its thin atmosphere. And you can see that it had water a long time ago. There's evidence of old lake beds on Mars. Jupiter is the largest planet in our solar system, and its great red spot is a huge storm that's 4 times as big as the Earth. Saturn's rings are made up of lots of ice and rock. Uranus, our 7th planet from the sun, is tilted over on its side. It must have gotten hit a long time ago. That's the important thing to remember about Uranus. It's that it's tilted. It's not straight up like all the other planets. It's tilted all the way over on its side. And finally, Neptune. Neptune is our 8th planet from the sun, and it takes Neptune a long time to circle around the sun. Many years, over 150 years it takes to go all the way around the sun because it's so far out in space. All right, you guys. That's all there is on the test. I really hope this was helpful. If you have any questions, please email me. And good luck on the test, and good luck studying.